Hello everyone. I'm Ms. Niveta T, working as Assistant Professor at Food Technology Department in Hindustan College of Engineering and Technology. In this lecture, we are going to see about chemical, nutritional, and microbiological changes in irradiated foods. Irradiation is basically a non-thermal technology used in food products to kill the microorganisms and prolong the shelf life of the foods. Sources of irradiation. Generally, the energy spectrum consists of two different radiation sources. One is non-ionizing radiation and ionizing radiation. The type of radiation suitable for food irradiation are ionizing radiation because they have the energy to break up the molecules and form ions. The common ionizing radiation used as food irradiation sources are X-rays and gamma rays. Among the two irradiation sources like gamma rays and X-rays, the commonly used form of gamma rays is cobalt-63 and another one source of gamma rays is cesium-137. These are the two common types which are used for industrial processing of food materials. And the one another type is X-ray emissions, which is having a maximum energy of 5 millielectron volts. Radiation dose. The quantity of radiation energy absorbed during the processing is called radiation dose, which is measured by the unit called gray. The safe level of irradiation is up to 10,000 gray. There are three different zones like low dose, medium dose, and high dose. Less than 1 kilogray can be used for delaying ripening, controlling insects and parasites. Medium dose is used for reduction of foodborne pathogens, and high dose is used for sterilization. Effect of ionizing radiation on food. The composition of food and its physical state will reflect on how radiation treatment is influencing the food composition. The absorbed dose, dose rate, and facility type, presence or absence of oxygen, and temperature are the common factors which will influence the effect of ionizing radiation on the foods. Generation of radiolytic products. Due to the reaction of radiative energy with the chemical components in the food, radiolytic products such as free radicals and excited molecular ions are formed, which are very reactive in nature. For example, the gamma irradiation of aerated water will form hydroxyl radical, which is a radiolytic product. The both intermediate and the stable radiolytic products are often expressed in a G value. The G value of hydroxyl radical is 2.8. But when the foods are irradiated in air apart from water, the G value will be different. From the primary irradiated product, a chain reaction starts and it gets multiplied in chain length. Because of this, chemical classes such as hydrocarbons, furans, alkyl cyclobutanones, cholesterol oxides and aldehydes are formed. Effects on food constituents. Protein structures are made up of amino acids. When irradiation occurs in foods, it changes the dissociation, aggregation, cross-linking and oxidation in the proteins. Gamma irradiation of hazelnuts at 10 kilogray induced aggregation and denaturation of proteins, resulting in moderate effects on the protein structure. The changes in lipids due to irradiation are affected by the factors such as lipid concentration, their formation such as unsaturated, monounsaturated and polyunsaturated fatty acids, presence of antioxidants, environmental conditions such as light, heat, oxygen, moisture and pH, the type of irradiation treatment, type of storage and storage conditions. The high fat content in the food products are the major causes of lipid oxidation and formation of free radicals. To overcome this, use of low temperature, reducing the presence of oxygen and use of antioxidants can overcome lipid oxidation in foods. In the research, use of natural antioxidants like oregano and rosemary extracts in beef burger subjected to E-beam irradiation where the dose was up to 7 kg and then they were further stored in the frozen storage up to 90 days showed a great capacity to reduce the lipid oxidation. When gamma irradiation is applied to foods, the carbohydrates in the foods gets converted into the simpler forms of monoaldehyde, formaldehyde and acetaldehyde and hydrogen peroxide, which are the main radiolytic products. The water soluble and the fat soluble vitamins in the foods are having different sensitivities to irradiation. Thiamine, riboflavin, vitamin B6, B12 and niacin in the absence of air have reported fair stability to irradiation. The fat soluble vitamins have the following decreasing order of sensitivity to irradiation. Vitamin E has higher sensitivity whereas vitamin K has lower sensitivity to irradiation. Microbiological changes in the foods. When irradiation is applied, the microorganisms present in the food undergo the following changes, especially in their DNA strands. The direct ionization of nucleic acid happens, which will lead to the lesions produced in the genetic material. They also form single-stranded breaks and double-stranded breaks. This kind of microbial changes will improve the keeping quality of the foods as these changes are lethal for microorganisms. The irradiated foods are endorsed by several organizations including US Food and Drug Administration, Center for Disease Control, American Medical Association, US Army Surgeon General, etc. There are also certain restrictions on radiation processing of foods. As per the guidelines provided by Atomic Energy, Radiation Processing of Food and Allied Products Rules 2012, all the irradiated foods must be distinctly identifiable so that they are not subject to further irradiation. Only those irradiated foods can be re-irradiated which are permitted under the regulations. And the personnel who are undertaking the radiation process must have the minimum qualifications and trainings as prescribed for the purpose under the atomic energy. Let's now see the labeling of radiation processed foods. Any food products which is irradiated must contain the statement declaring the type of treatment given for the food product. It must be in close proximity to the name of the food and all the packages of radiation processed food shall bear the international RADRA logo which is in green color and it must be declared in the label. The following details must be provided in the label such as name of the product, purpose of radiation processing, operating license number and batch number. The advantages of food irradiation are it requires no heat as it is a non-thermal technique. It can be used for packaged or frozen foods. It requires only less energy. We do not use any chemicals for the preservation of fresh foods. The nutritive value change is very minimal and it can be operated at high automation. The disadvantages of food irradiation are high capital cost. It can develop resistance to modified organisms, inadequate analytical procedures to detect irradiation in food, and there is no awareness among the public about the irradiation and its safety procedures. Hence, the public resists this kind of food products. Thank you.